Alright, so you've got something like this. Let's say 18x squared all over 6x to the fourth power. That one's pretty basic. We'll do another practice problem over here. Let's say 25x to the ninth power times v to the seventh all over 15x to the third times v. Okay? And we're just looking to simplify these equations. Okay? So the one on the left, okay, how am I going to solve that?
Practice problems or everything on here?
I don't know, we're just practicing. We're just doing a problem. Divide, okay. So how many times does 6 go into 18? 3. Okay? And I want to move everything to my numerator pretty much, so I'm going to say 3x to the what?
6.
Nope.
No, 6.
Okay, second power is kind of correct, but not right.
Third. Negative second.
Negative second power, okay? Because we're dividing by that x to the fourth, okay? So now we take it to x to the negative second power because we just did 2 minus 4. Well, that gets us negative 2, okay? So 3x to the negative second power. We did this all day yesterday, now it's like, okay. All right, 25x to the ninth times v to the seventh all over 15x to the third times v. All right, how can I simplify this? Divide, okay. By what? Or what can I simplify by, I guess? 5. Okay. So how many times does 5 go into 25? How many times does 5 go into 15? 3. Okay. Can I simplify 5 over 3? Nope, they're both prime. It's not going to work. Okay. Now what about my x values? Okay. I want my x to be in my numerator. Okay. So I'm going to say x to what power?
12.
Yeah. Okay. Subtract what? 9 and 3. Okay, which gets me 6. So I'm going to say 5x to the 6th power, and then I need to talk about my v variables as well. What am I going to say, Colton? Nope. V to the 6th power. Okay, because we subtract, and this one. Yep, it's understood that there's a 1. Okay, so we do 7 minus 1, and we get v to the 6th power. Okay, is that it? Yep, that's everything. Okay. I think that's really all you need. I mean, there's negative values, there's other stuff like that, but that's pretty much all that's going to be on your worksheet. We have that one with a rectangle. Let's do that one. Okay, so you had a rectangle. In case you didn't know, even though it looks like a square, it's a rectangle. Even if it was a square, it was still a rectangle. Okay, so let's say this over here is 3x to the third power, and then down below we've got, let's say 7x to the fifth power. Okay, I want to know what the area of that square is equal to. Or the rectangle. Huh? 10? No? Yes, no? How do we find the area of a rectangle? Multiply, okay? So what do we do? Okay, so 3x to the third power times 7x to the fifth power. All right, what am I going to do with the values out in front, Stephen? Multiply, okay, 3 times 7 gets me 21. Okay, x to the third times x to the fifth is going to equal
8.
X to the 8th power. okay, because we add those together. We go 3 plus 5, that's going to give me x to the 8. Alright, and so that's the area of this whole rectangle. 21x to, oh, too big, to the 8th power.
What if there's not two numbers?
What if there's not two numbers? Well, then you just multiply, because it's a 1 out in front, right?
Okay.
Because then, like, if this wasn't a 3, and that's not a 3, then that means we're just going to have a 7. So,
Okay.
cool.
So when you're dividing, then when you're dividing, you subtract the exponents, and then when you're multiplying, you add them.
When you're multiplying, you add them. When you're dividing, you subtract them. So if we had, like, 14x to the 9th power, and it was all over 7x to the negative 3rd power, well, now we're subtracting what? What am I subtracting now?
9
Well, 9 minus negative 3, which is going to give you... Okay, what happens when we subtract the negative? Becomes a positive, goes up, whatever you want to say. Okay, so it's going to be x to the 12th power. And then what's 14 divided by 7? 2. Okay, so I get 2x to the 12th power. Alright? Make sense?